ይስጥልኝ ተማሪዎች ከዚህ በፊት በነበረ ሌሰን መጨረሻ ላይ የጠየኳችሁ ጥያቄዎች ነበረ። ይሄውም በኤሌክትሪክ ከረንት ዴንሲቲ እንዲሁም ኤሌክትሪክ ፊልድ ስትሬንግዝን ተጠቅመን በኦምስ ሎን እንዴት አድርገን ዲተርሚን እንደምናደርግ ነበር የተነጋገርነው። ስለዚህ አንድ ጥያቄ ጠይቄያችሁ ነበረ። Can you find an expression for the Ohms law which is equivalently represented as resistance is equals to voltage over current? So previously we have found the Ohms law, or we can state Ohms law as current density to that of electric field strength is given as conductivity. Therefore J can be expressed as conductivity times electric field strength. This was originally stated by George Simon Ohm. This is the Ohm's law. Now, can we determine this expression, the usual expression, the common expression for Ohm's law? Is this one. Therefore, to determine this, previously we have already discussed that current density is electric current I over cross-sectional area A. And we have also took a segment of wire having a cross-sectional length A, like this. Therefore, this is L or change in L. It's possible to take this. Therefore, we have a cross-sectional area E. Therefore, can we determine the electric field between these 2 points? Here we have point A and point B. The potential difference between A and B, or the voltage, it's possible to say the voltage between A and B, can be given as electric field E times L or change in L. It's possible to have such an expression. I hope in Unit 4 you have already discussed this. Therefore, electric field can be expressed as E is equals to V potential difference over change in L, or we can possibly substitute this as L, V over L. Then let's resubstitute on the Ohm's law as what? Instead of J or charge current density, it's possible to have current I over area is equivalent or equals to the conductivity times, instead of electric field strength, it's possible to substitute as V over L. Now, let's try to collect the material properties all together. Therefore, when you rearrange this equation, we can find an expression, such an expression that potential difference here over current I, length and conductivity can be represented here as what? Length L over conductivity sigma times cross-sectional area A. Students, previously the inverse property of conductivity is known as resistivity. We can resubstitute it using resistivity. We know that resistivity is the material property of limiting electric current. Therefore, resistivity can be expressed as inverse of conductivity. When we substitute here, resistivity instead of 1 over sigma, it's possible to have resistivity length over cross-sectional area A is equals to what? Potential difference over electric current I. Therefore, from this term, the quantity on the left side, which tells us about the geometrical property of the material, which is tells us about resistivity, the type of the conductor, length, the length and the cross-sectional area of the wire. Therefore, this is known as the geometric property of a given conductor. Therefore, it's possible to substitute this as resistance. Resistance, let's write it here. This as resistance. Resistance. We can symbolize resistance as capital R. Therefore, we can substitute here as R is equals to resistivity length over area. So students, what do you mean by resistance? What is resistance? Well, Resistance, I hope you have already discussed this in your lower grade. Resistance is the opposition to the flow of current, or it is a property of a resistor or a conductor which limits the flow of current, Therefore, when you substitute here in this equation, resistance can also be rearranged and equivalently expressed using voltage over current I. Look here, resistance can be expressed using this geometrical property of materials, or resistance can also be equivalently expressed using this. This is what we call Ohm's law. This is the famous Ohm's law. Ohm's law. Students, this is the one we are usually using and expressing Ohm's law. And in this case, the SI unit of resistance can be expressed as what? The SI unit of resistance, R, is equals to the SI unit of potential difference, V, over the SI unit of electric current, I. What is the SI unit of potential difference or voltage? I hope you already mentioned it. It is known as volt, in honor of Alexander Volta. V over. What is the SI unit of electric current? We have already discussed it previously. It is known as ampere. Ampere. And it can be expressed as A. So voltage over ampere is known to be Ohm. Ohm, in honor of George Simon Ohm. It can be symbolized using a Greek letter omega. Okay, students, by the way, this is the capital omega. You have learned this as also omega. This is small letter omega, used for a frequency. Usually we note it as frequency. Therefore, omega, ohm, is the SI unit of resistance. 1 ohm is equivalent to that of 1 volt per ampere. Now, students, let me ask you a question. What would happen to the resistance if you increase current? What would happen to the resistance if you increase current, keeping the voltage constant? Please try that. Students, I hope you have tried this at home. Resistance never be affected due to the increment or the decrement of electric current. Resistance only affected due to the geometric property of the material. Resistance is only affected by the geometric property. That means resistance is affected only due to what? Resistance is affected only due to the type of the material, due to the length and the cross-sectional area. These are the factors which affect resistance. The type of the material, means resistivity is a factor which affects. The other is the length and cross-sectional area. Cross-sectional area of the wire or the conductor. That is the one which, these are the factors which affect resistance. Increasing current might not affect resistance. Resistance is the property of a material. Increasing current means equivalently or linearly we are trying to increase the voltage. So whenever you take the ratio, it remains constant for a given ohmic material. So students, resistance is expressed as voltage over current, and this is Ohm's law. Then students, can you try to solve some problems? Students, I hope you have tried to solve those problems. Now let's try to solve it together. The first question is asking us to determine current density. The question says that find the approximate current density of a given wire, which is silver, the current density of a silver using the quantities already given. Therefore, current density of a silver. That is what we are asked. You know that, students, electric field can be measured using Newton per Coulomb, or equivalently measured by volt per meter. Therefore, we are asked to find the current density. Therefore, your solution will be from the Ohm's Law, current density can be represented as sigma times E. Therefore, when you substitute this, it's also possible to express this as 6.3 times 10 to the power of 7 Siemens per meter. Therefore, when you substitute this, 6.3 times 10 to the power of 7 times, instead of this, we can substitute like this. Therefore, at last, we can find the current density to be 7.56 times 10 to the power of 8. The unit of electric current density is ampere per meter square. I hope you have tried this. Now let's try to solve the second problem. The second problem states that it asked us to find the resistivity of a given material. There is a given material, and that given material is copper. Through the copper wire, resistance is already given. The length and the area is already provided. Now let's try to collect those constants, those given variables. What are the given variables? Well, the given variables are: 1, the length of the copper wire is given to be 1 meter. At last, we are asked to find the resistivity. The resistance is measured or found to be 0.13 ohm. Then what is the resistivity of this material? The material is copper wire. Actually, it's possible to find it on your standard physics books, but mathematically we can determine this. The third example to find a potential difference. We have resistance and current measured. Therefore, it's possible to determine a potential difference or voltage. Let's solve it together. So what are the given quantities? What are the given quantities? The given quantities are, first, we have resistance in ohm. Resistance in ohm. Resistance in ohm. It is 40 ohm. And the current measured through the given wire is found to be 0.05 ampere. Now we are asked to find potential difference or voltage. Potential difference. It's possible to call it voltage, V. Solution. From Ohm's law, from the expression of Ohm's law, it's possible to find resistance as what? Resistance is equals to voltage over current. Therefore, it's so easy to find this. Voltage V is equals to current I times resistance R. Therefore, when you substitute this 0.05 times resistance is 40 ohm. When you calculate this, you can find it to be 2 volt. 2 volt. Students, I hope you have tried to find the solution. You are answering this well. Then next time, we'll try to see about resistance and networking of resistors. What is resistor? Students, can you answer this? What is resistor? Resistor. Resistor is an electrical component. It's a very basic electrical device or a component which limits the flow of electric current. Is an electrical component. We can call it a device which limits the flow of current. Resistance across circuits can be symbolized using a zigzag line. There are two methods or ways of representing resistance. You can symbolize it using a zigzag line or a box, or like this. You can use like this. Then resistor possesses resistance property. Previously, you have already discussed that resistance appears due to the type of the material. Here we can have a copper, silver, or any other material. Resistivity, it might have a length L and cross-sectional area. Due to these material properties or geometrical property, this resistor or this device will possess resistance. So here you have a resistor. It is a device. It consists of a property which opposes the flow of current. It's known as resistance. The device is resistor. The property is resistance. And here you have resistivity. Resistivity is all due to the geometrical nature of the material. Therefore, now let's see about the networking of these resistors. How do we connect resistors across a circuit? Well, there are two basic techniques of connecting resistors. And this method of resistor networking, resistor network, or we can call it combinations of resistors. Resistor networking is a means or a technique of connecting different resistors. Basically, we have two methods of connecting resistors, and these are series combination of resistors and parallel combinations of resistors. So what is the difference between these two combinations? Students, can you try that? I hope you have already learned this in your lower grade. Resistance can be connected in series and in parallel. And at your home, you might face a different technique. Usually, in your home installation, we have a parallel combinations of resistors. Therefore, when resistors are connected in series, they must be connected end to end, alternately. When resistors are connected in parallel, they must be connected side by side, meaning all similar terminals must be connected together. Therefore, the difference is that there is an end-to-end combinations of resistors, and here we have side by side combinations of resistors. And as well, there are a technique to identify the types of connection, and that is the flow of electric current. Here, in series combinations of resistors, there is only one way of current flow. There is only one only one way of current flow. But here we might have several ways or different ways of current flow. There might be different flow, direction of flow of current, direction of current. Therefore, let's take 3 resistors and connect them in parallel and series. Let's take 3 resistors. Let's name them to be resistor 1, resistor 2, resistor 3. Students, can you try to connect these resistors in series and parallel? Well, from this definition, so from this explanation, it's so easy to connect these 3 resistors in series and parallel. When we are trying to connect them in series, we should have to connect alternately, meaning these resistors will have, or these resistors have, plus and minus terminals, plus, minus, plus, minus. Therefore, when you are trying to connect end to end, meaning plus, minus, plus, minus, plus, minus. Here plus, minus, plus, minus, plus, minus. Let's take a source like this. Plus with plus of the first resistor, minus with minus of the last resistor. This is resistor 1, this is resistor 2, this is resistor 3. And the other point is, can you connect these resistors in parallel? Well, we should have to connect these resistors using side by side, meaning we should have to connect them together. Let's do it here. Let's try to connect these resistors plus with plus, plus with plus, minus with minus, minus with minus. Then we should have to connect this with the source. This is parallel combination. Okay? This is the parallel combinations of resistors. So what would happen to the current, voltage, and resistance of these circuits while they are connected in series and parallel? Students, next time we'll try to find those difference. The combination of resistance in series might have a different property on current, voltage, without of a parallel combinations. So we'll try to solve this and study till next time. ተማሪዎች እንግዲህ የዛሬን ሌሰናችንን በዚህ ጨርሰናል። ሁለት ጥያቄዎችን ጠይቃችኋለሁ። እንግዲህ ባሉን የመገናኛ ብዙሃን ሚዲያ አድሬስ ትልኩልናላችሁ፣ እነሱን ቼክ እናደርጋለን። እነዚህም ጥያቄዎች ምንድናቸው? የመጀመሪያው ጥያቄ what is charge? What is the definition of charge? What do you mean by charge? ምንድነው? እሱን definition እንድሰጡናላችሁ። ሌላው what is the similarity between charge and mass? What is the similarity of mass and charge? ተማሪዎች እንግዲህ ይህንን ሁለቱን ጥያቄዎች ሞክራችሁ በአድራሻችን ትልኩልናላችሁ ማለት ነው። እናመሰግናለን ዛሬ ስለተከታተላችሁን። ኔክስት ታይም እስክንገናኝ መልካም ጊዜ ይሁንላችሁ።